Astronomers love to put things into categories, classes or lists. Let me tell you about all of them that are widely recognised. See, bright dots in the night sky can first be put into catalogues for the sake of listing them. They don't have any properties special to them, they just exist. And if I wanted to tell someone else about something very specific I was looking at in the night sky, I'd give that thing specifically a name so we were on the same page rather than me looking at one object and my friend mistakenly looking at the object right next to it. Messier is probably the most famous catalogue, 110 objects that Charles Messier saw in the night sky and he thought were interesting. Another, called the Caldwell catalogue, found another 110 objects that complemented his first catalogue. So we had 220 objects in the night sky with standard names, outside of real names given to some very significant objects. However, we were about to go into high gear. The major star catalogues are the Henry Draper catalogue for 225,300 visible stars, the Smithsonian Astrophysical Observatory star catalogue with 258,977 stars, the Bonner this catalogue for 324,000 stars, the Hipparcos catalogue for 118,000 stars, the Tycho 1 and 2 catalogues for about 2.5 million stars, the Bright Star catalogue with about 9,110 of the brightest stars, the Gaia catalogue with about 1.8 billion stars individually listed and named. Outside of stars, the new General catalogue with about 7,840 non-star objects like galaxies, and the Index catalogue with 5,386 complementary objects. These all categorise things that are beyond the Milky Way or are clusters. Listing them is good and all, but what if we wanted to know what each were all about? Good question. For stars, we can use the Harvard classification system. Every star has a letter to indicate a spectral class. This basically just means how hot it is and what kind of light it's giving off. Is it bluer, redder, white, etc. There are O, B, A, F, G, K, and M in order from hottest to coolest. Hotter stars live shorter lives and are generally larger and also brighter, but not always. So each letter is always divided into 10 numbers 0 through 9, with 0 being the hottest end of that band and 9 being the coolest. We're still not finished though. We add a Roman numeral 1 to 6 to categorize how bright it was and how big it was. After these 3 parts, you can add various English letters to represent any peculiarities specific to that star and what would be for someone interested in taking a look at said object. Most stars are good for this classification because they live fairly uniform lives, at least for our time frame. However, the General Catalogue of Variable Stars documents everything and anything that likes to change from time to time. Because this is a catch-all for all the special snowflake stars that fell through the cracks in the Harvard classification, there are about 100 different prefixes you can add instead of the traditional O through M. So I won't go through them all, but I'll give a link to a source which lists them all in the description if you're interested. The good thing about this is that the catalogue paired with Harvard can categorise every single star in the night sky without question, because if there's one they can't, they make up something new and put it there. Beyond just stars, the Hubble Galaxy classification categorises galaxies into either elliptical or spiral, with a number to denote a specific variant of the elliptical, and a letter to denote a specific variant of a spiral or a barred spiral. Distinct clusters of stars use the Trumpler classification, which has 3 parts, like Harvard. How concentrated the stars are ranked 1 to 4 in a Roman numeral, a range of magnitudes from 1 to 3, and the letter to indicate how many stars are within the boundaries of said cluster, with P being poor, M being medium, and R being rich. The Shapley-Sawyer classification similarly puts globular clusters of stars on a scale from 1 to 12 in Roman numerals for how dense they are, 1 being the densest and 12 being the most sparse while still defined.